Hi everyone, good afternoon. My name is Lillian. I'm on the FinTech team here at AWS, and we are excited to bring you this session with Myles Hosford and Darren Boyd, both extremely valuable members of our security specialist team, here to talk to you today about how you guys can be meeting MAS Cyber Hygiene Notice requirements on AWS. So it's been a super important topic as we're getting closer to kind of the date of the deadline for this, and we've got a lot of requests from the FinTech team, so this should be a really good session. Some housekeeping items before I hand it over. We will be sending the slides at the end of the session. You'll probably get them from us later today or tomorrow, so that will be in your inbox. Separately, we do have another webinar coming up next Monday that is focused on how to adopt spot instances if you're running EKS. So super easy way to reduce your AWS costs by about 70 to 95 to 90% by moving over. So that will be included in the follow-up as well. And lastly, every Friday, we are also doing a virtual office hours called Friday FinTech Clinic. So if you have any questions about, setting up on AWS, whether it's security, whether it's networking, any kind of AWS best practices, come join us every Friday, 2 p.m. I'll send you the link to sign up there as well. Cool. Thanks, everyone. Hope you guys have a great session. Myles and Darren, over to you guys.
Thanks, Lillian, and good afternoon, everyone. I'm very excited to be presenting you today alongside my colleague Darren and Lillian on the Cyber Hygiene Notice 655. So just a bit of background, Darren and myself are Principal Security Solution Architects here at AWS, and we get the very pleasurable job of working with all of you, our customers, to help you design secure systems when you move to AWS and help you navigate kind of security considerations and aligning your security strategy to various regional regulations. Obviously, today is just focused on the cyber hygiene from MAS, but we do help a lot of you and have experience throughout the region with other regulatory frameworks as well. So today we're going to be looking at the MAS Cyber Hygiene Notice, and in terms of where that fits in from a regulatory perspective, I just want to take 1 or 2 minutes to kind of point out some other regulations and guidelines that you probably are considering in a more broader strategy if you are regulated indeed by the MAS. So the first one would be the outsourcing guidelines from the MAS, which was recently updated in 2016. And the outsourcing guidelines are really around you ensuring that you have a proper framework in place when you outsource part of your business operations, particularly the use of cloud, to service providers like AWS, and making sure that you have a proper contractual framework in place and that you are exercising good risk management. Sorry, there's someone really loud on the move. Can I move someone? Maybe Lillian. Sorry, Lillian. There we go. Okay. So in addition to the outsourcing guidelines, there are also the MAS technology risk management guidelines, which are a little bit more deeper from a technology perspective, and they actually call out kind of requirements and guidelines to follow through the implementation and the use of IT. So there's a lot more technical control considerations within the guidelines, ranging from everything from access control to physical security of your data centers to proper change management, software development lifecycle, and through to the use of proper cryptography to protect customer data. Now, what happened in kind of August 2019 was that the MAS published the Cyber Hygiene Notice, which was an attempt from MAS to basically level up the cyber protection implemented by firms here in Singapore. And the difference between a notice and a guideline is that actually the guidelines, like the TRM, for example, should be implemented by the organization with a level that is kind of in line with the risk or of the strategy of the organization, and they're not legally binding. Now, the difference with the Cyber Hygiene Notice is that it is a legally binding framework that regulated entities must adopt kind of by law. So it was published in August 2019 with a kind of a grace period of a year. And then that's kind of given regulated entities the best part of 12 months to think about how they plan to meet the Cyber Hygiene Notice. So let's take a look at kind of at an overview of what it really is. And it's essentially a set of 6 security features or security controls that should be implemented, starting off with securing administrative accounts. So wherever you have privileged accounts across your organization, whether that's at the operating system layer, databases, or applications, those administrative accounts should be appropriately secured. The second security control that MAS calls out is the requirement to apply patches on a timely manner. I think everybody would agree that one of the main kind of sources of security issues or incidents is with unpatched, servers and workstations and applications. So MAS has identified the real requirement there to make sure that you're patching your software frequently. The third control requirement that the MAS expects is that you should be, implementing and following security standards and proper security baselines to ensure that the resources that you're using and that you deploy are done so in a secure way, okay, and well governed. The fourth security control that the MAS calls out in the Cyber Hygiene Notice is really around establishing a strong network security perimeter and making sure that you're protecting those networks from cyber attacks and DDoS attacks, and making sure that only authorized traffic is actually coming in and out of your network. So we'll jump into some details of that in a moment. And then the fifth control that is part of the Cyber Hygiene Notice is really around protecting your critical systems and components from malware attacks, so implementing proper malware protection controls. And then finally, the sixth control that is documented by the Cyber Hygiene Notice is really around making sure that you have multi-factor authentication on your privileged accounts and on any accounts that have access to essentially critical customer information. Okay, so those are the six controls. We're going to be diving into a bit of detail on each of those control areas and how they can be implemented on AWS using a combination of AWS native services and features that we provide by the platform. Before we do that, though, I think it's really important to understand that control implementations in AWS is a shared responsibility. So I'm going to pass you over to my colleague Darren now, who's going to talk to you about what the shared responsibility model means, and we're going to use that to set the stage for the controls that we'll revisit later in the webinar.
Thanks, Myles. So as a customer of AWS, you really have a shared responsibility between you as our customer and us as your provider. So if you look at the shared responsibility model, the orange bit at the bottom is the stuff that we take care of. And typically what this includes is things like our global infrastructure, all of our regions and availability zones, data centers that underpin those, the network connectivity between them, but also the compute and storage platforms that our services are offered to you on top of. Now, in the typical kind of server environment, this is up until the hypervisor layer is up to where AWS has responsibility. Now, above that line is the customer responsibility as yourselves, where you get to make certain choices around what operating systems you run, around what software you run, or whether or not someone has access to a certain capability, which is on your side of the shared responsibility model. So really important as we go forward through this, it's true for this notice from MAS and any other regulation, is that you do need to consider what we as a provider are doing for you in context of that regulation, and also what you need to do on your end. So let's talk about the bottom half, which we call security of the cloud. This is the portion that AWS takes care of. And really the key point I want to drive home here is for the portion that AWS takes care of, we're not asking you to trust us. We're not saying, hey, Darren says we do this stuff, therefore they do it, it's fine. Certainly not. What we do is we have many, many compliance programs all across the globe that we have third-party auditors come in and audit us against. So the real point here is not just saying, trust me, it's actually trust these third-party auditors from big name firms that you're all familiar with. Now, we do these at a global level. So global programs like our SOC program, SOC 1, 2, and 3. We have the ISO suite in the 27000 series. We have PCI DSS for payment card industry at level 1. These are all international standards that we are attested to and third-party audited against. But we also do things regionally. We have a large swath of them across the United States that align to things like the FIPS validation for our hardware security modules. There's various areas of FedRAMP that we have multiple levels of attestation. And as we go down, you'll start to notice that we have Europe and also Asia Pacific. So specific to our discussion here is we include things like the OSPAR certification, which is specific from the Associated Banks of Singapore And we have that attestation today and available to you. Now, all of these reports that I'm referring to that are produced by our third-party auditors are available to you free of charge. And I'll show you a little bit later on where you could actually get those from. But the reality is that diagram I showed you earlier around shared responsibility model is true, but it's very conceptual. In truth, it's slightly more nuanced than that. And why that is depending on the services that you use from us, the line of responsibility actually moves. So the diagram that you saw earlier aligns very well with what we consider to be our infrastructure-based services or infrastructure as a service. So things like our VPC, our virtual private cloud, or EC2, our virtual servers in the cloud, where you as a customer get to select your operating system. But of course, with that choice, you also inherit that responsibility of maintaining that operating system and maintaining the software that runs on top of it. But if you start to look at some of our other services, which we call our container services, this is where we take away some of that responsibility from you. A good example of this would be RDS, which is our relational database service, where we could expose to you a database engine, something like MySQL or Oracle or Postgres, where we don't expose the operating system to you. Hence, you do not have to think about or reason with how do I patch and manage that over time and lifecycle it, because we do that on your behalf. So you really just have to think about, okay, well, I've selected a database engine. I'm going to provide AWS with a maintenance window, and AWS will automatically patch my database engine at this level. And then on the most extreme, we have what we call our abstracted services. Now, probably the most well-known one in this area is Amazon S3, which is our high durability object store. Over here, there's no operating system, there's no storage array or any of that. None of that is exposed to you. You simply have an API where you put objects and you get objects, and AWS is taking care of everything else. All you have to consider is, well, what data do I put in there? Who do I give access to that data? And what degree of encryption do I select to use? So if you look at this continuum from left to right in terms of services and their shared responsibility model, is on the far left with something like EC2, you get a lot more customization headroom because you have all of those choices you can make. But with that, you also get all the responsibility of managing it. On the other end of the spectrum, with something like S3, it's far less customizable for you, but also far less responsibility for you, and has our best practices built in. So we have industry experts working 24/7 around the world, securing and monitoring our platforms. You get that by using services more and more to the right in the spectrum. Now, why this is particularly important is if you think about this notice, is the more you take a service on the right, the more we're doing for you in the context of the notice or any regulation for that matter. So make a conscious choice when selecting services on how much of that responsibility you really want to carry and how much of that responsibility is really differentiating you in your business. Keep in mind that our business is technology and hyperscale cloud. This is our business. This is what differentiates us. Does it differentiate you, is the question. So with that, we're going to go through the 6 categories that are in the notice. So as we're going through these, think about the services you're using or planning to use, and think about how this relates to your choice in terms of what you need to think about. So I'll hand it back to you, Myles, to talk about administrative accounts.
Thanks, Darren. And yeah, just want to re-echo kind of what Darren said there around the benefit of using AWS from a security perspective. And one of the main benefits is that you inherit these controls, as Darren was saying, right? So when you start using services that are further on the right, you're going to get a lot more automatically inherited that AWS has already implemented. So, you know, super useful for you as a customer. So what I would say is as we go through these 6 control areas and we talk about some of our best practices, feel free to ask any questions in the chat. I know we've got 1 or 2 come in already, and we'll be addressing those as we go through the controls, but also we've set away some time at the end to actually have an open Q&A. So if there's anything that you'd like more detail on or that wasn't maybe clear enough and you want to go deeper, feel free to throw the question in the chat and we'll try to get to as many of those as possible as we go through. So the first control objective that the MAS sets out, is, as I mentioned, is all around protecting administrative accounts. Now, MAS within their actual notice document, I think does a very good job of trying to define all of the different various components of where you might find administrative accounts across your environment. Okay, so they specifically call out operating systems, databases, applications, and things like security appliances that would be scattered kind of, traditionally through an on-premise legacy network. In the cloud, obviously, you've still got administrative accounts for operating systems and databases and various other appliances that you might have throughout your network. But in addition to that, you've also got the AWS account. Okay, so your AWS account that you use for cloud, and that has administrative components. So let's start there and talk about that. So when you open an AWS account, the very first user that you get is what is known as the root user. Now that root user is a super user. It can't be restricted from a policy and roles perspective. So it essentially has access to do everything across your AWS environment. And because it's so powerful, and it can essentially terminate resources, delete servers, close your entire account, it's very important that you as a customer take special measures to make sure that that account is protected. And what we actually recommend customers to do is some simple best practices initially, like enabling multi-factor authentication, which I'll come to towards the end, which is a control objective on its own as per the notice. But enable multi-factor authentication, create a long password, but more importantly, do not use the root account for day-to-day business operations. Typically you should be using what we call an AWS identity and access management role, or a user in a role, which is not the root account. And why that is important is if the root account gets compromised, or if someone is logged in with a root account and perform some misconfigurations, the impact could be kind of devastating. So it is really important to protect that root account at all times. So once you've protected the root account, you've enabled MFA, and you have a strong, you've got a strong password. It's really then time in your organization to start looking at using IAM to create groups and permissions for your users based on the principle of least privilege. And what we mean by that is basically creating roles that can be used by your users that operate in the cloud, but based on their job function. So AWS can help you do that with managed policies, where you can essentially say, these people within my organization are part of my database administrator group. Therefore, I want them to have full access to the RDS database services, but I don't want them to have the ability to make modifications to my network and to my to my firewalls, to my security groups, and whatnot. So following the principle of least privilege is very important to further protect your administrative accounts, and making sure that you have multi-factor authentication and a strong password policy turned on. Now, what I've talked about so far is basically human access to AWS, where you have an individual logging into the web console to perform actions like deploy resources, make administrative modifications. And that's one way of interacting with AWS, but we also do have a way of interacting via the command line and via our APIs directly. And typically customers would do that with what we call access keys. Now, historically, access keys would be generated when you open your new account. And what we recommend customers do is, if they don't need to have these API-driven access keys, is that you simply, first of all, remove them from your root account. But if you do need access keys to access the AWS environment via APIs, or you're building some automation and you're using the command line, what we recommend is that you actually use the AWS Simple Token Service. And what that does is that it authenticates your user request when you kind of authenticate to the service, and it will vend you short-term temporary credentials to interact with AWS. Now, what's good about that is that the short-term credentials, essentially expire at that, after a certain timeline, and then you don't have long-term access keys laying around for 100 days, 200 days, or even, in some cases, thousands of days that have administrative actions to the capability to access your AWS environment. And we have seen, hackers exploiting the fact that some customers have long-term access keys, and if someone's able to steal those access keys that have administrative capabilities, then also the hacker from wherever they are in the world might have the ability to access your AWS environment using your credentials. So very important to start moving away from long-term credentials and long-term access keys, and using services like the AWS STS service to vend these short-term time-bound credentials. Now, what you can do as well to further protect administrative accounts is using IAM policies. You can specify conditions under which the policy would be executed. So, for example, I've mentioned multi-factor authentication a few times. You can actually specify a policy that's attached to your users that certain API actions that you might consider high risk or sensitive would only be allowed to be executed if the request was performed using a multi-factor authenticated session. In addition to that, you can use conditions in your IAM policy to prevent which source IP addresses can actually access your AWS environment. So in a combination of the multi-factor authentication condition plus the source IP check, you can actually add multiple layers of controls to your policies that you're using. Now, in addition to protecting your AWS account and kind of the servers that operate within AWS, we also see many customers wanting to protect their secrets that they use to connect to other systems. Now, those secrets can be things like database connections or database credential strings. Those might be API keys that you're using to access a middleware within your organization. And historically, those secrets have been stored in clear text. Many developers will store kind of clear text passwords within the source code of their application. And obviously, from a security or a cyber hygiene perspective, that's kind of, it makes it very easy for an attacker to find those credentials on your server in clear text, in flat files, and then use those credentials to move laterally around the network. So using something like AWS Secrets Manager, you're actually able to vault these secrets and credentials in a secure storage that to use them, you need to perform appropriate authentication and authorization. The credentials can automatically be rotated and managed and stored for you. And also what's really nice about the Secrets Manager service is that all access to it is auditable and logged. So from a security team perspective, it's very powerful when the AWS native services interact with CloudTrail, which means anybody accessing those secrets to access, middleware or databases or whatever the secrets are for, there's a very robust auditable log for your security team to review. So those are some best practices for managing administrative accounts. I'm going to hand over to Darren now, who's going to run us through control objective number 2.
Thanks, Myles. Okay, so now we're going to change gears and talk a little bit about security patches. And I did mention this when we were going through the 3 shared responsibility models, and that was intentional. So if we think about the expectation here is that security patches need to be prioritized in terms of criticality, and there should be an expectation of how quickly one should be going about implementing those patches in line with that criticality and the time frame that you set organizationally. So let's think about, well, where would you need to apply security patches? So referring back to those 3 security shared responsibility models, let's start off on the left again. So if you're running EC2 instances, virtual servers in the cloud, be them Windows or Linux, because you're choosing that operating system and have full control of it, you also have the responsibility of patching that. Now, one of the services we provide to help you do that automatically at scale is using AWS Systems Manager, which has a built-in capability for patch management. And really what this defines is a schedule that your organization has defined, but we define it as a codified schedule together with different groupings of your assets. So perhaps you have higher risk assets that you want to patch sooner than lower risk assets. And that's often whether or not perhaps they're internet facing or not. And you can define all of this in a schedule within Systems Manager and have this automatically start to deal with your operating system patches across your fleet. Now, as we start moving across and we start thinking about containers and container orchestration, if you think about it, we're really adding another layer of operating system to have to patch. Because if you have your underlying operating system on which your containers are running, each container in and of themselves is also an operating system that needs to be patched. So do be very conscious in making that decision when you go down the path of, be it Kubernetes or our Elastic Kubernetes service or our own native ECS service for containers. Now, fortunately, like in many times with AWS, we do offer options to take away that heavy lift from you. So in both of our key container orchestration services, EKS, which is Elastic Kubernetes Service, and ECS, our Elastic Container Service, both of them we offer an option called Fargate. And in this option, effectively, it becomes serverless from your perspective, and hence there are no operating systems and service for you to run and manage from a patching standpoint. But do keep in mind that the underlying images that you're using to deploy your containers do need to be patched, and the application that runs on top of that. Part of what we do provide some visibility into is image scanning, as we call it, as part of our ECR service, which is our Elastic Container Registry. As part of checking in your images, you can actually do vulnerability assessments against those images, which could help you plan and infer which security patching you should look to prioritize. Now let's think about databases. Again, if you were to run your own EC2 instance and run your own database engine, you would have full responsibility for patching that operating system. But if you elect to use something like our RDS service, our relational database service for MySQL or PostgreSQL, Oracle, we take away some of that heavy lift from you. Again, there'll be no operating system exposed to you for you to patch. And also, so long as you provide us a maintenance window, then we will go ahead and do those patching of the database engine on your behalf. Taking that to the extreme, if we think about those abstracted services, we have services like DynamoDB, which is our key value store database, NoSQL. In this circumstance, there isn't even a database engine for you to patch and manage. So we take that away from you as well. Finally, applications, right? So as we've gone up the stack and we've considered all these options, there's still applications themselves that have vulnerabilities that require patch management and life cycling over time. So consider that both in terms of applications that you have built in-house, but also applications that perhaps you've gotten from our partners. So through the AWS Marketplace, you're able to get access to a number of our partner technology solutions and deploy them into your account. Again, that partner and the marketplace will provide you a mechanism for managing the patch lifecycle over time. So with that, I'll move on to security standards. Really, the expectation here from MAS is that you need to define a security standard for your organization. Now let's put that into context. Perhaps you want to choose certain encryption methods based on the criticality of data. So perhaps you have internally a mechanism for classifying your data, be it PII or highly sensitive or whatever the nomenclature is that you use. But then you would want to define security controls that are aligned to that data classification. So for example, that could be if it's highly restricted information, you maybe want to encrypt it at rest using a customer managed CMK, which is a key material within AWS that you can fully manage access to and manage that segregation of duties. So once you've written that up in a document, it really comes to the next phase is, well, how do you actually enforce that throughout the life cycle of that application and of that data? So the way we like to think about how you enforce security standards is by codifying those security standards into 3 places. The very first place that you want to consider that is in your infrastructure itself, by defining your infrastructure as code in a templated language. So the AWS native capability here is CloudFormation, where you can define all the resources and the relationships between those resources in a templating language and have that automatically provisioned or deprovisioned for you through a pipeline. Now, this has some really good capabilities. Primarily, you can version control your infrastructure, but like you do code review on code, you can also do an infrastructure review on your infrastructure. But aside from that, it also allows you to do some checks against your security standards before the deployment actually proceeds. So imagine in that scenario which I described, you want data of a certain classification to always use a specific kind of customer managed CMK for encryption. You could actually enforce that as part of a linting rule that you put in your pipeline, so that if that test fails, in other words, if something is not operating within that security standard, that the build will fail and not get deployed. This is the ultimate preventative control, meaning that even before something gets provisioned in AWS, unless it meets your security standard, it won't be. Also, the earlier you move those linting tests in your development cycle, the quicker it's going to be for you. Because imagine a developer moves something from their desktop environment to a dev environment, and as part of that, that code migration has these linting tests applied. Immediately they would know whether or not they're out of compliance. And solving problems early in the stage saves a lot of time versus trying to solve them later in development cycle. And it really reinforces and becomes a teachable moment for developers on how to operate within your security standards. But now once something is actually deployed into your account, and it's meeting all your security standards, how do you know throughout its life cycle that it will remain in line with your security standards? And this is where you want to look at both preventative and detective controls within your account. So on preventative, this comes back to what Myles was talking about earlier around the principles of least privilege. Making sure individuals and roles within AWS that you define only have access to perform actions that are in line with their job role. Second of all is that you can put conditions in your policy to say things like, well, you can't take this action unless the security standard is being enforced through one of those condition keys. Now you can do that organizationally using AWS organizations, where you could actually apply this codified version of your security standard as a service control policy and apply it at the top of the organization in a way that it cascades down and enforces it across all of your accounts. It's a really powerful way of centrally managing that security standard in code. Now, not everything can be preventative controls, unfortunately. Certain things require a certain amount of time to elapse or a certain amount of additional context in order to determine whether or not something is in or out of compliance with your security standard. And this is where we tend to rely heavily on detective controls, which is using capabilities like AWS config rules. You can define your security standard in a desired state in a rule. For example, data that's tagged, S3 buckets that are tagged with this data classification require this kind of data key. And actually, anytime that there's a change in your environment, it will reevaluate against these rules and surface them as either being in compliant or out of compliant. And then you can take action. And you can take action via AWS Security Hub, where you're able to see a cross-account view of all of the compliance and out of compliance against your desired states, and then actually trigger, be it tickets to support teams or even automated remediation to step in and to bring the resources back into compliance with your security standard. So really think about them as before the cloud, at the cloud, and in the cloud. That's the full life cycle of how you can manage your security standard and enforce it at scale. So with that, I'll hand back to you, Myles.
Thanks, Darren. So control objective 4 from the Cyber Hygiene Notice is all around establishing a strong and robust network perimeter to ensure that only authorized network traffic or authorized traffic is inside your network, and obviously unauthorized traffic is denied. So with that, I want to take a look at kind of network perimeter defense through the lens of 4 different kind of domains, okay? And those will be network security, so making sure that you have a strong network inside AWS. In addition to that, then I'll jump into some details around application security. So what can we do with layer 7 to make sure that only authorized network traffic is accessing your applications? Then we'll take a look at the edge security, which is essentially around, being able to use our highly scalable, fault-tolerant content delivery network to shoulder some of the, of the incoming traffic to your account to provide you scalability. And then finally, DDoS protection. So, how are you protecting against hacker groups and the botnets that are trying to send large volumes of data to your application? So let's take a look at network security first. And I'm sure most of you on the line would be familiar with our VPC, or Amazon Virtual Private Cloud, which is essentially your logically isolated section of AWS that it belongs to you as a customer. So you have the ability to make a private network. You can configure the subnets that are within your VPC. And with that, you get the ability to actually create or modify what we call security groups. So security groups are really the primary network security control that you use inside AWS. They're host-based stateful firewalls, essentially, that will sit around your resources and servers in AWS. Primarily, you would be protecting your EC2 instances with security groups, but we do support other resources that have ENIs or elastic network interfaces. So things like Lambda functions and RDS and other resources that expose essentially an endpoint inside a virtual private cloud. So the security groups, as I mentioned, are stateful, and because they're host-based and every single resource that you have to have them, we really do see customers having a significantly better security posture inside AWS than a traditional kind of flat network. Now, what I mean by that is traditionally, organizations would typically have a firewall at the perimeter, so, between the internet and the DMZ, or the DMZ and an internal network. But once the attacker has actually managed to kind of breach the perimeter and get inside the network, typically it's very easy for attackers to move laterally to other servers. Okay, so once they've compromised the database engine, historically it would have been easy for malware or ransomware to spread around the network and infect, all of the servers and assets that you have. Now in AWS, because everybody has these security groups, and you have control over how these security groups allow inbound and outbound network traffic, your actual network flow within your application can be very, very fine-grained in terms of what's allowed to actually talk to other resources and servers. So to be very clear, you own the security groups and how they're configured, and you can configure both inbound and outbound rules that kind of will be evaluated by your security group. Now, what's nice about the security groups as well is that they're essentially, although they are host-based, they're a little bit decoupled from the host operating system. And what I mean by that is, let's say that you have a network administrator, or one of your, your administrators of your server accidentally misconfigures a whole bunch of ports to be opened, like Telnet, FTP, ports that have clear text protocols and you potentially don't want. Now, if they do that at the operating system layer, okay, so they install vulnerable services, or they accidentally install SSH or Telnet or FTP, those ports will not be accessible at the network layer if the corresponding security group also doesn't open those same TCP or UDP ports. So in addition to it kind of being a stateful host-based firewall, it really provides an extra layer of control inside your network, which means even if someone misconfigures an operating system or installs a vulnerable service, the security group acts as a kind of a defense in depth as well. Now, in addition to the security groups, we also have a secondary network security control, which is our network access control lists, or NACLs, that you have operating as a kind of a subnet layer. And if you want to, you have the ability then to configure the NACLs, which provide an extra layer of defense in depth from a network security perspective. Okay. So once you've configured your VPC and you've decided which public or private subnets you want and what resources you want to face to the internet versus being entirely private, now we're going to take a look at the application layer, or layer 7. So common attacks or attackers or unauthorized kind of attackers would try to do things like cross-site scripting or SQL injection attacks against your web applications. And what those are classes of attacks where attackers might be trying to modify the database queries that would be executed on your database, and if successful, would potentially have the ability to kind of extract sensitive data, potentially financial transactions and usernames and passwords. So a common control to protect against those sorts of undesirable or unauthorized network traffic at layer 7 is to implement a web application firewall. So at AWS, we do have our own web application firewall that you can use that sits in front of your application and your servers inside the VPC. And as web traffic flows through to your application, the AWS web application firewall will evaluate that traffic against a set of rules. Now, there's a couple of different ways that you can acquire these rules. AWS provides now a managed rule set which aligns with the OWASP Top 10, which is a list of kind of controls or vulnerabilities that many customers want to protect against. So again, things like cross-site scripting, SQL injection, rate limiting attacks, IP blacklists, and stuff like that. So we do provide a managed rule set. Now, in addition to that, you have the ability to kind of create custom rules yourself, where you have to do a little bit more configuration, but the WAF is essentially flexible, where you can create your own rules. And then finally, we've also got a kind of a web application firewall marketplace, where you can actually take the rule packages from third-party vendors that are available in our marketplace, and then you can take those rule bases and deploy those into the AWS WAF, okay? So in addition to kind of protecting at the application layer of your application, many customers do look to build a highly resilient and fault-tolerant architecture that has the ability to scale, to take on more traffic, or if there was a potential DDoS attack. And one of the ways of them doing that is by using a service called Amazon CloudFront. So Amazon CloudFront is our content delivery network, which can be used to essentially distribute kind of content using our edge locations and points of presence all around the world. Now, what's good about using CloudFront from a security perspective is that actually you move the public let's say, interface or endpoint into your network to be further away from your actual servers and your systems. Okay, so CloudFront you can think of like a kind of a guard, sits in front of your web application or the servers, and then it has a very highly distributed network that it can draw upon if there are any kind of large-scale attacks, and can provide you that extra kind of scalability for your architecture. Now, in a similar thread to kind of the reasons for using CloudFront is some of the reasons of using AWS Shield, which is a DDoS mitigation system. So AWS Shield, just like the WAF, sits at the perimeter of the AWS cloud and has the ability to essentially screen layer 3, layer 4 traffic as it comes into your AWS environment. So it does things like, it uses kind of pattern-based recognition and also some machine learning models to actually detect volumetric DDoS attacks as it comes into your AWS environment, and then kind of drop that traffic before it reaches your server. So we've got two different types of Shield. There's one version called Shield Standard, which is available for free, and everybody gets the benefit of AWS Shield Standard today. And then we also have an advanced version. Now, there are many different kind of benefits of why you might consider the Shield Advanced, but really the two primary ones that I see customers enjoying the most is the first one. If you use Shield Advanced, you get access to our 24/7 DDoS response team. So if we actually observe an ongoing DDoS incident against your application, our 24/7 DDoS response team is available and will step in and help you, and automatically write inline mitigations with the WAF or other tooling to stop the attack. In addition to that, if you're a Shield Advanced user, you also get the benefit of the cost protection. Now, if you do have a well-configured and well-architected AWS workload, ideally, as traffic is coming into your environment, and if it is a potential DDoS attack, your application should automatically be designed to scale up to meet the demand of the incoming traffic. So, for example, if your servers need to add new web servers to auto-scaling groups, or there's any sorts of compute and memory scaling from an incoming attack, without Shield Advanced, obviously your billing and your pricing model would reflect the increase of capacity that your application is now operating at. In the Shield Advanced cost protection model, any increase from scaling to mitigate a DDoS attack is basically protected under the Shield Advanced program. Okay, so just a little recap there on the kind of the network perimeter. I think you can see that we've got a kind of a broad range of different services that are available, but primarily you're going to be needing to ensure that you've got a well-designed virtual private cloud network that is, again, designed on the principle of least privilege and reducing your attack surface as much as possible by very well-defined security groups. And then whatever services that you're exposing to the internet, whether that's a public web application or otherwise, you're going to be wanting to use a combination of our DDoS mitigation and web application firewall services, so WAF, Shield, and CloudFront, and also Route 53, which is our DNS service, to essentially provide you a very scalable and protected perimeter facing the internet. Okay, so I'm passing back over to Darren, who's going to run through control objective 5.
Yeah, so what happens when your network perimeter fails? This is normally when malware gets in. So I feel normally organizations are very focused on the detection of malware, but I'd like to suggest we take a bit of a step back and think about kind of it more holistically in terms of how one should be thinking about malware. Now, if you look at the statistics out there, the way that malware gets in almost exclusively is through phishing, where individuals are being targeted either in mass or spear phished for targeted attacks, where they're being tricked or cursed into actually going and installing software or going to a website they would have otherwise not have, which is all leading to leveraging typically either a known or unknown software vulnerability that allows for software to be installed and this malware to get a foothold in your network. Now, this user awareness is really your first line of defense, is getting in your organization a good program, a training program around the awareness of phishing and related attempts and approaches that attackers use to take advantage of the human aspect, because that's going to get you a long way from preventing malware from getting into your network in the first place. Now, there are a number of vendors out there that offer phishing simulation. I know I used to be in a bank, and every now and then I would receive something that looked like a fish, and then we actually had a button that we could press in our email to say, is this phishing? And if you were correct, you kind of got kudos for it, right? What it was a program to kind of get people comfortable with being able to identify phishing and know that they should be alerting the security team. So I can't put too much focus on how important this is as your first line of defense. But that defense will not always work. So now we have to think about, well, what if we have a bad day? Well, first and foremost, you need a good backup and recovery strategy. Most malware has a motivation, and that motivation is typically either espionage or holding you to ransom for some kind of monetary gain, right? These are kind of two broad categories. Now, in these circumstances, in order to recover from a malware infection, you need to be able to recover to a known good state. This means taking backups. This means testing your backups. Now, in AWS, all of our backup services are backed up by Amazon S3, which is designed for 11 nines of durability, extremely high durability storage, and can be tiered at different cost and access models. So if this is long-term archival storage, you can use our Glacier or Deep Glacier service to store this kind of data for an extremely long period of time for an extremely low cost. Furthermore, our storage solutions offer versioning, meaning that if, for example, a backup got corrupted or had malware in it or was ransomware, because we have versioning, you could be able to go back to a previous version of that data storage. If you want to take that to the extreme, we even have an object lock feature where once objects are written to the data store, they can only be read, they cannot be changed. So this is really valuable for that kind of data that you really do want to protect, primarily against threats like ransomware. Now, on the detection front, there's kind of two broad approaches here. The one that most people are familiar with is where you have some kind of an agent installed on your desktops or your servers or your virtual machines. And yes, this is a really important step, and we have a great partner ecosystem of big names that that work with us and have agents that are available for the EC2 instances that you're using. So definitely encourage you to look on the marketplace for those big names that you know. But it's beyond endpoint protection. There's also the network behaviorals type detection that is really powerful. And this is where Amazon's GuardDuty service, which is a managed threat platform in the cloud, really comes into its own. It takes in three primary data sources, one being your API activity through CloudTrail, the others being VPC flow logs, which is your network traffic traversing through your VPC, and third is DNS logs. And we push this into the GuardDuty service together with our own threat intelligence that we've gathered from our AWS security team of monitoring our, so many of our customers around the world in all of the various regions that we have. We've taken that threat intel together with two additional vendors that we've partnered with and apply that to your traffic. And this gives a very high degree of signal to noise in terms of if bad things are happening in your account. This could be your host is communicating with a known bad command and control server. It could be that your host is communicating with a Bitcoin or crypto mining ring. So it's a very strong indication of compromise. Or even that credentials that were on your EC2 instance have been used outside of your VPC, which is again a very, very strong indication of credential compromise. But in addition to those threat analysis that we do, we also put it through a AI and machine learning model that we've developed over time. And how this works is once you enable GuardDuty in your account, it takes 7 to 14 days to baseline activity in your account. And really what it's doing is it's trying to determine what is normal in your account. What is the normal kind of API activity? What are the kind of normal network flows in your account? And then it sets that as a baseline. And then it triggers into an active mode where if things start to deviate outside of that baseline based on our models, you'll get a very, very high signal to noise ratio alert from GuardDuty that there's very likely bad stuff happening in your account. So the key message there is when you're thinking about detection, think beyond just endpoint protection, but also think about network and behavioral-based detection. Finally, when all this, if it eventually goes wrong, and unfortunately in security it typically does, is you need to be prepared. How are you going to respond to a malware incident? And the real important point here is less about tools and capabilities that we have, but more about preparedness. Make sure that you're writing playbooks, which are loosely, almost like a loose plan on how you would actually address a malware threat or any other threat for that matter within your account. What would be your first step? Are you going to escalate? Are you going to gather logs? Is your first thing you want to do to isolate? Or is your first objective to attribution? It's really important to have your priorities straight, because this is a very high pressure, time-sensitive time of your life when you're doing incident response. And those playbooks help you think about how you're going to do that. But that's not enough. You can't wait for a security incident to practice. It's really important that you simulate events. Now, typically what we suggest to our customers is that you set up what we call a game day. So you go into the guard duty documentation, you find one of the findings that it will hopefully never alert you on, and you can start to say, well, let's build a playbook around this. Very high level, just in markdown language or whatever you're comfortable with. And now let's pretend that this has actually happened. Let's test and practice our playbook and our response. And what inevitably happens off the back of that exercise, and make it fun, bring some pizza and beer or whatever, is people will have suggestions on how to improve that playbook. And that's really true about incident response. It's an iterative process. You don't write one playbook to address malware. You write it, you exercise it, you learn, you improve. Because as your security posture is improving, the capabilities of the attackers and adversaries are also equally improving. So it's important that you keep iterating and improving on malware. Now, later on, I'll show you some resources that we have that specifically talks about how you can think about the ransomware threat specific to AWS. So with that, I'll hand over the last category to you, Myles.
Thanks, Darren. So I get the exciting topic of multi-factor authentication to talk to you all about. And private joke, me and Darren, when we were divvying up the 6 control objectives, we both realized that multi-factor authentication is a very interesting topic. So I got lumped with it at the end. So just conscious of time, I don't want to spend too much time on this actual control objective, but what I do want to say is that we broadly see a need for multi-factor authentication across your AWS environment in 3 broad categories. Okay, the first one is your actual AWS account itself, and I said at the start how important it is to make sure that both your root user, but also any other IAM users that you have, are protected using the AWS multi-factor authentication. We do support both virtual tokens and hardware MFA tokens. So you can go to our MFA portal and you can see what form factors we support there from essentially from a hardware perspective. Now, in addition to that, protecting your AWS account, you're going to want to make sure that you have multi-factor authentication enabled for your systems and your operating systems. And typically, customers will do that by leveraging their existing identity provider or IDP. And typically, that would be something like Microsoft Active Directory, or you might have something in your organization that uses Kerberos or LDAP. And if you're using those already, then you would likely just continue authenticating your systems in AWS following a very similar pattern. Now, provided that your existing identity provider, supports MFA, which they would, then you should be okay to meet that control. Now, in addition to that, we also see organizations using, in addition to AWS, many different types of software as a service or third-party applications. Now, what you want to try to achieve as an organization is centrally managing your identity in one single location. You don't want to have 6 or 7 different identity providers that all are servicing different applications and different business applications for your staff. So that's why it's a good idea to have some sort of central identity management strategy, and maybe consider implementing something like AWS single sign-on, which allows you to centrally manage your identity resources in a single place and use that identity pool to then authenticate your users in third-party software as a service applications. Okay, and then the final kind of bucket of where you need to look at MFA is when you're building your own applications and you want to provide end user access or provide a way of your users, authenticating to your fintech portal or your payments application or whatever it is that you guys are building. But Amazon Cognito is essentially an end user identity pool, which provides kind of full life cycle of registering users, managing the password reset function, and of course also supports multi-factor authentication. Okay, so three kind of different buckets there: the AWS account, your operating systems and SaaS, and also making sure that any end users that you are, managing the identities for your customers or your consumers, that you have a proper MFA strategy in place, and Amazon Cognito can help with that. Okay, cool. So
Okay,
that's
thanks,
the
Myles.
control objective. Yeah, thanks, Darren. Pass over to Darren, who's going to run us through what resources we have to help you.
All right, so I'm going to start with Whitepapers. So just if you don't know, we've had this for quite some time. It was updated last year, was the AWS Guide to Financial Services and Regulations in Singapore. So this is kind of the one-stop shop you want to look at in terms of where you want to start your journey in terms of thinking about, what does it take to operate in AWS in Singapore, given the various regulations. The other two that I've called out here is we've just this month done an update to our Security Incident Response Guide, which I touched on during the malware section. Really, really valuable document to think about how you can, leverage not just AWS, but also like the nuanced capabilities that we have to really lift the bar in terms of your incident response as it relates to malware or any other security event. On the malware topic, our public sector team released an ebook that's available free of charge in terms of how you can think about planning for and responding to the ransomware threat in particular. A really good read, and suggest that you can bring that one down. The other one I want to bring to your attention, and this is very specific to today's topic around Notice 655, is that we generate what we call workbooks. Now, what workbooks are is effectively we look at a number of regulations, and today we're talking about MAS, and we consider each of the requirements within those regulations, and we look at, well, what do we as an AWS bring to the table on our side of the shared responsibility model, and we document mapped control statements that we're audited on. So effectively, this is the stuff that you're inheriting, quote unquote, for free from AWS by leveraging the platform, some of that heavy lift. But we put that in the context of the specific regulatory requirement. But equally, what we do is we look outwardly towards you as our customers and we say, well, what guidance can we give you that's in line with each and every one of these requirements? The way we do that is through our well-architected program. For those that aren't familiar with well-architected, it's effectively our version of what good looks like. It's, solutions architects like Myles and myself all over the world have worked with many, many customers across many different industries. And there's a lot of good tribal knowledge in terms of how one should think about designing a cloud native application that's performant, that's secure, that's COPT optimized, etc. And we use those best practices to provide that guidance, but in the context of each and every one of these requirements within the regulation. Now, where possible, and it's not always possible, we take that one step further, which is some of these requirements can actually be inferred through code, whether or not an S3 bucket is encrypted, whether or not your EBS volumes are encrypted, whether or not you have a very, very permissive IAM policy. We can actually programmatically infer these things through AWS config rules, which I mentioned earlier during the security standard section. So where possible, we even map it further all the way to that to be a consideration of a control that you could implement within your account, again, in the context of the particular requirement or regulation. And the ones that I've called out here are the TRM, the Technology Risk Management Guidelines from 2013. But just last month, we released one of these workbooks for the Cyber Hygiene 655 notice as well. So I highly encourage you to having a look at that to kind of consider some of the controls and the way you can think about addressing your AWS workload in the context of these regulations. Next up, I'll just touch on this really quickly. So we have the Association of Banks of Singapore. For those that aren't aware, they're a group in Singapore that comes up with a number of industry views around financial services. One of their cloud-orientated publications was the Cloud Implementation Guide, which got a version 2 a few months ago now. We as an AWS actually opted to get certified against being an outsourced service provider, and we have that attestation, which is called the OSPAR attestation. And again, we have a location which I'll show you in a moment where you could download the report of this attestation. So this is really demonstrating AWS's commitment to align to those high expectations that the Association of Banks of Singapore had for cloud service providers. So again, something you as a customer get for free by using the platform. Now I've mentioned all these things, where can you get them? First and foremost, I want to direct you to Compliance Center. This is at atlas.aws. What this allows you to do is from a country picker, select a country. We have over 50 countries represented, but if you chose Singapore, it will give you resources, some of the ones that I've mentioned here, like the workbooks, the white papers. It's a really great way for you to get a sense of what is the cloud permissiveness within a country. In Singapore, it's very much green, and what resources and tools do we give you to help you align? And also AWS Artifact. AWS Artifact, where I spoke about those third-party attestations we have for our SOC reports, for PCI, for OSPAR, those are provided through AWS Artifact, which is a tool within the AWS console. The reason it's there is that there is content that is provided under NDA, so hence why it's not available on our public website. You would just need to click through, well, read and click through the NDA there and accept it in order to download these artifacts free of charge. This is also where those workbooks are that I described, because the AWS control statements are also provided to you under a non-disclosure agreement. Last thing from me, we have a lot of services in AWS, and I'm very proud of it, but I also recognize that it can be very daunting. Over 175 services, how do you secure them? So last year at our Reinforce conference, we announced that we would have a dedicated security chapter in each of our public documentation, where we will provide security controls that you can consider on your side of the shared responsibility model, but also some of the controls that we have baked into the service that we're doing on your behalf. So I highly encourage you to look at these security chapters when you're kind of evaluating or maybe reviewing some of the security postures of AWS services that you're using. Off to you, Myles.
Thank you, Darren. And just conscious of time, we're on the top of the hour. So I want to close out with kind of 3 next steps that I recommend everybody that's dialed into the webinar today to go and take a look at and review to really level up and enhance your security strategy on AWS. The first one is to ensure that you have a security capability and trained staff. It's kind of, before we start thinking about implementing controls, I think it's very important that organizations understand that they should be looking to have their staff trained on AWS security with the ultimate goal of becoming AWS certified as a security practitioner. So we do have a very structured learning path for your security teams to review. Kind of starts off with our free online training called AWS Security Fundamentals. So if you go to aws.training and take a look, there's a free self-paced training course that you can go through, and then the curriculum then flows through to actually sit in an exam, which is a certification and an attestation of your security knowledge. Then the second step that I would say is very important for customers to evaluate is our well-architected framework. So Darren's made a number of references to this. It's important because it covers 5 different pillars: operational excellence, security, reliability, performance, and cost. And then specifically within those sections, like security, for example, there will be a number of prescriptive kind of questions that AWS would ask your customers that you can use as part of a self-assessment. So for example, there's an example on the screen there of question 9 from the security pillar, which basically tries to determine how you as an organization are thinking about encrypting your data address. Then, as you can see from the screenshot there, there's a number of different solutions, and you can perform a self-assessment against your own application. And the output of that self-assessment essentially will be kind of, red, amber, green, or high, medium, and low risk issues that have been identified by the well-architected tool based on our prescriptive best practices. Now, in addition to that, as Darren mentioned, we've got these, cyber hygiene and MAS TRM workbooks that actually take the controls out of the well-architected framework and map them through to the actual regulation. So very interesting resource developed by Darren and the team, and you should go and check that out in AWS Artifact. The final step, I would say, is once you've trained your teams and you're performing architecture reviews, is what to do if you need additional support from a security perspective. So we've got a very healthy ecosystem of both partners and AWS's own professional services function here in Singapore. You can find more details about our partners on our partner portal on the APN via our website, or if you reach out to Lillian and the team, I'm sure they can make introductions to the various partners that we have operating in Singapore. And these partners themselves will already have security specialized or security certified capabilities, and they can advise you on how to meet the requirements of the TRM and also the cyber hygiene notice to make sure that you have a strong security posture in AWS. Okay, so 3 nice and simple next steps there. So again, conscious of time, and I know we've gone over an hour. I think it took us a little bit longer to go through the 6 control objectives than we anticipated. So we've got a couple of minutes for some Q&A, and I know there's been some questions coming into the chat. So what we'll do as well is when we reply with the follow-up email, we'll be able to reply to some of these questions in the follow-up email to make sure that you have the answers that you want. So there was one question that I'll take first of all around when we were speaking about the security groups and the network perimeter. Someone's asked a question saying that kind of inbound rules are relatively simple because you kind of know what traffic is coming into your environment, and I agree. And the challenge is usually with outbound traffic. And are there any tips on how to baseline for outgoing traffic? So what I would first of all say is that because the security groups are stateful, provided that the incoming connection establishes a connection with your application, then any kind of outbound traffic that's based on that connection would automatically be allowed because it's a stateful firewall. But for any traffic that's originating from inside your network, where your servers need to connect out to the internet to maybe download patches or updates, typically is why they would be used, or if you need to connect to counterparties and other partners, then yes, you will need to take a look at your outbound traffic. What a number of customers do is actually flow that traffic through kind of a reverse proxy or some sort of perimeter appliance where the traffic will be analyzed on the way out of the network. And what I would recommend is if you did put in place a kind of a reverse proxy and routed all the traffic through that, you would have a very good sense of what traffic is going out of your network, and you'll start to see kind of maybe Windows updates or some other sort of patch management and update tools. Many customers then take that a step further and use those kind of middle kind of reverse proxy appliances to inspect the traffic, but also apply kind of DNS or fully qualified domain name whitelisting to make sure that the connections going outside the network are only to authorized and approved servers. And then basically that's another preventative control against malware inside your organization. Okay. And then the final question, I guess we got
I'll
time
take
for.
one here.
Yeah, go on, Darren.
Oh, sorry. I just saw one around the best practice around patching and testing through SIT, UAT, and once it's tested, how do you take it to prod? The reason I picked this one up, just going back to when we spoke earlier about security standards and this notion of infrastructure as code, what Cloud Ready allows you to do is to not think about your infrastructure assets as permanent assets, right? There's no reason that they have to exist for as long as your application exists. They can be built and destroyed as and when you want. And there's really this movement around what we call ephemeral infrastructure, where effectively you would set a goal that perhaps your servers are only ever alive for, let's say, 14 days or 30 days, and that on every deployment, it's being re-provisioned from scratch. Now, why I bring that up is because one, cloud allows you to do that, but two, it's a way of actually doing patch management at scale is by actually, for example, rolling forward to new operating system images in your pipeline and then creating a whole new environment, which then you do a deployment, a blue-green deployment to, and then your previous deployment, which is now out of date, can be completely deprovisioned. So think about it more as rolling forward with new infrastructure as opposed to trying to patch infrastructure in its place, in its current place.
Thanks, Darren. So conscious that we've gone 10 minutes over, I think we'll end there. Hopefully that was useful to you to kind of come up to speed with the various different services that we have at AWS that can help you meet the 6 different control objectives required by the MAS Cyber Hygiene Notice. I think to just recap a couple of key takeaways that obviously we will be sharing the slides in the follow-up email from Lillian and the team. So you'll have the slides available. And then if you really want to dive deep on this, I would suggest that you take a look at atlas.aws, as Darren mentioned. That's our financial services compliance center. click on Singapore, and then you're going to have access to kind of all of the artifacts and workbooks and detailed mappings that the teams have developed to support you on your effort to comply with the MAS TRM, Cyber Hygiene Notice, and other regulatory requirements around the region. So I would start there. And then in addition to that, train your teams and people as an aim for certification, and also perform well-architected reviews of your design and of your current architecture. So hopefully that was interesting for everyone. Thank you for your time and sticking around over 10 minutes run over there. But I hope you enjoy the rest of your afternoon. Thank you.
Thanks, everyone.